In this video, we're going to use graphs of quadratic functions to help us solve quadratic equations. Take a look at our first example. The graph of y equals negative x squared plus 2x is shown below. Use the graph to solve the following equations. Our function is given by the equation y equals negative x squared plus 2x, and we recognize that as being a quadratic function. Here I'm writing it, the function, in function notation. And you can see that it's in standard form with a equal to negative 1, b equal to 2, and c equals to 0. And because the a is negative 1, then we expect the parabola to be downward facing, and it is, right? And you can see also that if we wanted to, we could use our vertex formula. X equals the opposite of b over 2a, which would give us what? The opposite of b over 2 times negative 1. So x equals 1 should be the coordinate of the vertex, and it is the x coordinate. All that is being said is just so that you can realize that this parabola that's shown here is indeed the parabola that follows or that matches this function. Okay? And so what we're going to do is we're going to use the fact that we have the graph of the parabola here to actually solve these equations a, b, and c without having to do the usual algebra that we would have to do, like such as factoring or quadratic formula. We're instead going to use the parabola. So what do I mean by that? Well, let's take a look here. So in A, you want to solve for x in the equation negative x squared plus 2x equals 0. Well, if you recognize that that's our function on the left, you're absolutely right. So what are we looking for? Well, we're looking for the x that would give us a y value of 0. Okay? So we're going to come over here to the graph and we're going to look at the points on the parabola where the y value is 0, because those are the points where we will find the x's that solve the equation. So those are the x-intercepts, aren't they? So we've got two. We've got this point here, 0, 0. Right? So we've got 0, 0 as one of the intercepts, and we've got the point 2, 0. And, but we're solving for x. They're asking us to solve the equation. So they're not looking for you to give them answers as order pairs. They actually want you to give them just the x coordinates of these points. So to solve the equation, x equals 0 or x equals 2. And see how we use the graph without doing the algebra. Now, algebraically, and we're just going to do one algebraically so you know what you would have done. If you said factor, you're absolutely right, because this binomial on the left-hand side has a GCF, right? So that does factor. So let's let me put it up here. Negative x squared plus 2x equals 0. We could factor out an x, and then we would have negative x plus 2 equals 0. And then we would set each of these two factors to 0. And so see how we would get x equals 0 for the first factor. And then we would get negative x plus 2 equals 0. And if we add x to both sides, do you see how we get the x equals 2? So this would be solving the quadratic equation algebraically. That's what I just showed you, okay? But when your homework problems ask you to solve the equation graphically, then you're going to use the graph and the order pairs on the graph to help you find x. Okay, hope that makes sense. So let's take a look at B. Now we're looking for the x values in our function that give us a y value of 1. Y is 1. What's x? And so we're going to come over here. Let's use a different color. Let me see. Okay, we're going to come over here to the parabola again, and now we're looking for a y value of 1. Okay, so do you see it here? It's the vertex, isn't it? The vertex has a y value of 1. So when we solve this quadratic equation, the x coordinate where the y value is 1 is 1. So notice that we didn't get two different answers. And we've discussed before how quadratic equations give you two answers. That's because this particular x equals 1 is considered a double root. And what that means is that if you were to factor the quadratic, if we were to do this algebraically, you would get two factors of, you would get two of these. Okay? And so we call that x equals 1 double root because it's repeated. It's a repeated root. Okay, but that was just a little extra review from work that we've done before. Now let's look at C. So C, we are looking for the x, y is -3. Okay, so now y is -3 here and here, right? So y is -3 at the point, at the order pair -1, -3, and y is -3 at the order pair 3, -3. So the x solutions are -1 or x equals 3. Okay, let's go to the next one. This one says the graph of y equals x squared is shown below. Okay, so here's our function. If you recognize this function as being the parent function that we discussed in another video, then you're absolutely right, right? So f of x or y or f of x equals x squared, and here's our parent function quadratic equation. Okay, has vertex at 0, 0, and the y-axis is the axis of symmetry. Everything's nicely symmetric with respect to the y-axis. Okay, beautiful. We're going to solve x squared equals 0. So using the graph, again, we're looking for y to be 0. That happens here, right? So y is 0. What is x? Well, according to our graph and according to what we know, x is 0. Okay? Because if we're looking for the square of x to be 0, aren't we taking the square root? We could do this algebraically very easily. We couldn't be using square root property. Okay, x squared equals 4. So let's look for order pairs where y is 4. And now a lot of you are thinking 2, and you're absolutely right, but there's 2 points where y is 4. So we get x equals 2 or x equals -2, as you can see, right, from the order pairs, because here's our x's that go with those 2 pairs, those 2 points where y is 4. And see again why when we're using square root property, we always do plus or minus. There's another reason. Okay, x squared equals -1. -1. Uh-oh. No graph. No graph in negative. There's no part of my graph has a y value of -1. Do you see that? What does that tell you about solving this equation? If you said D and E does not exist, you're absolutely right. So no solution, no real solution. Okay? No real solution. We've done previous work where we know that there's a complex solution, an imaginary solution, but there's no real solution. So does not exist. Okay, beautiful. Let's go to the last one. Okay, now we've got here the graph of f of x equals -x squared minus 2x plus 13. So let me just write that down here. So that's the equation. And we expected a downward parabola because of a being -1, so that's cool. And this 13, we know about this 13 being the y-intercept, and sure enough, there it is. Okay, here's our equation. We're going to use it now to solve f of x equals 14. So that means what? That means y is 14. Find x. Okay, so when you see the equations given in this function notation, this is what it represents. It says y is 14. What is the x that goes with a y of 14? And so back up here, there is our one point that has a y value of 14, and it happens to be the vertex. And what's the x value there? -1. So y is 14 at the vertex. The vertex order pair is -1, 14. So the solution, x equals -1. Great. F of x equals 5. Y is 5. What is x? Here y is 5 here, y is 5 here. Y is 5, the x that goes with that is 2, x equals 2. Y is 5, the x that goes with the left point is negative 4. So x equals negative 4. F of x equals negative 2. So now in the last problem, our graph didn't go down into the negative quadrants, but in this problem, our downward parabola does. So we do have solutions, real solutions. And let's see here. So x is negative 2 on the right-hand side. At this point here, 3, negative 2. So x equals 3 is a solution. And then the left point, x is negative 2 at, y is negative 2 at x equals negative 5.